This question involves sketching a quadratic curve by finding the points of intersection with the axes and the minimum point, but not using the method of differentiation. This is question number 20 from the January 2020 iGCSE paper. Let's have a look. So we're given a bit of a strange one here. We've got the curve C has the equation y equals 4x minus 1 squared minus a is greater than 4. So we've got a weird looking equation with this extra variable here of a, which we don't know the value of. It says using the axes below, I've put them over here, sketch the curve C. On your sketch, clearly show in terms of a, the coordinates of any points of intersection of C with the coordinate axes and the coordinates of the turning point. So first of all, in terms of a, that means we're going to have a in our answers. We're not looking for specific numerical answers. Our coordinates will have a in them somewhere. This part here where it says the points of intersection with the axes, so the coordinate axes, this is literally where it cuts the x-axis, where it cuts the y-axis, and then the turning point. And obviously this is a quadratic, so it's either a happy quadratic or a sad quadratic. Well, let's look at the state of the quadratic first. So if we look at our equation up here, if we were to expand that, we don't need to, but if we were to expand that, what are we going to get? We're going to get y equals 4 brackets x squared minus 2x plus 1 minus a, and then if we expand that further, we get 4x squared minus 8x plus 4 minus a. So if we look at the coefficient of x squared, it is the number 4. It is a positive. Therefore, we have a positive, we have a happy quadratic. So we have a quadratic that looks that way. It's a smiley face, not a sad face. So that's a good starting point. Now we want the minimum point of this. Now go back and look at the actual graph, because if we look at our equation, if we look at this, they've already done some work for you. Now, how can we make this as small as possible? Well, to make this as small as possible, this bracket here would need to be equal to 0. If x was equal to 1, we would have 1 minus 1, which is 0. 0 squared is 0, and times by 4 is 0. So if x was equal to 1, this would all be worth nothing, and we would have minus a. If x was a positive value, bigger than 1, we would have a value here bigger than 1, and squared would be bigger again, and then multiplied by 4 will be bigger again. So that's clearly going to be bigger than if x was equal to 1. And conversely, if x was less than 1, we would also have a value here, and this would then multiply by 4, which again would give us something bigger than the value of 0. So clearly, x for a minimum point must be equal to 1. So for the minimum point, for min point, x must equal 1, because that makes my bracket equal to 0, and then I have the lowest value. So if x equals 1, what is y equal to? Y equals 4 multiplied by 1 minus 1 squared minus a, which is 4 multiplied by, well, that's going to be 0 squared minus a, and 0 squared times 4 is 0. So my answer is negative a. So my y is equal to negative a. So my minimum point is going to be x equals 1, y equals minus a. I don't know where that is, but if you look at the graph on the right hand side, if we just declared that, say, that 1 is here, and we have to go down to the negatives. So if we say, I don't know, negative a, let's put it there for now, we may move it, that's going to be my minimum point. That's the bottom of my graph. Now, so that's actually the coordinates of the turning point, so that's actually the second part of the question done. Now we want the points of intersection. That is simply where it cuts the x-axis and the y-axis. So we want to find out what the values are when x equals 0 and y equals 0. Let's do this in blue. So let's say, what happens when x equals 0? What is y equal to? Well, y will be equal to 4 multiplied by 0 minus 1 squared minus a. So y is equal to 4 multiplied by minus 1 squared minus a. So y is equal to 4, minus 1 squared is 1, so multiply by 1, minus a. So y is equal to 4 minus a. So we know that when x is equal to 0, y is equal to 4 minus a. So if we look at that, we go, okay, so when x is 0, we are going to be cutting the y-axis at 4 minus a. And it tells us that a is bigger than 4. So that means that this value is bigger than 4. So if a is greater than 4, then 4 minus a is going to be negative. Now we know it's not the minimum point, we've already worked out the minimum point, so I'm going to go, it's got to be somewhere higher up than that. I'm going to put it there and say that that is 4 minus a, and that's a point on my graph. So it's going to cut through at that point there. So I now have 2 points on my graph. What about the x, where it cuts the x-axis? Well, it's a quadratic, so it's going to cut it twice, and we need to put y equals to 0. So let's move some of this stuff along and out of the way. Just take this if I can, and I'm going to put that over there, just out of the way. So what happens when y equals 0? I'm going to get 0 equals 4 bracket x minus 1 squared minus a. Now let's solve this equation. I'm going to add a to both sides, so it becomes positive over here. 4x minus 1 squared, divide by 4. A over 4 is equal to x minus 1 squared. Let's take the square root of both sides. So a over 4 equals x minus 1. And finally, add 1. Oh, actually, before I do that, we took the square root. Remember, square roots have 2 roots. So one is positive, one is negative. So I'm going to have 2 values there. So now then I add 1 to both sides. So I do 1 plus or minus the square root of a over 4 equals x. So we know that when y is equal to 0, x has 2 values. So we have 1 plus the root of a over 4. 0 is 1 point on my graph. And the other one is 1 minus the root of a over 4. 0. So that's the other point on my graph. Now remember, again, a is greater than 4. So if I look back at my equation here, if a is greater than 4, this is greater than 4, this is going to be greater than 1, so this will be positive. So this will be, so a greater than 4, so 1 plus the root of a over 4 is positive. So that's going to go on the right hand side. It's not only positive, it's going to be greater than 1, isn't it? And greater than 1. Greater than 1. So I'm going to have a point, maybe I'm going to put it, say there. Okay, that point there. And looking at the last point here, I have 1 minus the root of a over 4. And again, if a is greater than 4, this value again is going to be positive. It's going to be bigger than 1. So 1 minus something bigger than 1, this will be negative. So again here, 1 minus the root of a over 4 is negative. So it's going to be on the left hand side of my axes. I'm going to put it somewhere here. Now I need to mark on those points. So go back to the point here. This is 1 plus the root of a over 4, and this one here is 1 minus the root of a over 4. So that's this point here. I now have my 4 points. I have my 3 points where it cuts the axes, plus I have my minimum point, which means that I can now draw in my curve and try and do it as smooth as you can. It's not going to be pretty, but it's going to look something like this, like that. Now in terms of the exam, you must label the axes. So you must label this point here you must indicate the minimum point here, so probably I need to write that in just in case the examiner's being a bit naughty. So this is going to be the point 1 minus a, but it's pretty clear it's that because I've labelled 1 and minus a here. I've labelled my coordinates for this point and this point. In terms of the writing, I don't need to write this little bit down here. I think it's nice to put it in because it's just reaffirming in my mind exactly what is happening. But hopefully you can see how this question sort of pulls together.